Hi, I'm going to talk about a little bit about addition, subtraction, and the multiplication of graphs. I think from what some of you, the way that you ask question, I think some of you still having trouble understanding of this thing here, since they are one of the basic things of solving convolution for the last step, right? You're going to take a multiplication, a product of two graphs. So first of all, let's talk about addition of the graphs. Now, first for if I give you a unit step function, okay, so let's say u of t, then the unit step function is this. Okay? So essentially, it's all 0 here, and it goes up like that. Okay? Now then, u of t minus a certain number, let's say 2, and it goes to here. Okay? So if I give you another one here, let's say I call u t minus 3, so then it's 3 here. So let's draw these two graphs, ut minus 2, ut minus 3 on the top of each other. Okay, so 2 is here and 3 is here. And if I want you to construct a new graph, okay, which is u t minus 2 minus u of t minus 3, then you look at the subtraction. Okay, it's basically you do the subtraction essentially point by point, okay, at t equal to 2, 2.1, 2.3, something like that. And apparently when t is less than 3, and this portion is all 0, okay, and this is all 0 too. So 0 minus 0 is 0. When t is between 2 and 3, and here's 1, so 1 minus 0, okay, is 1. Okay, so then you do have something now. Now when t is greater than 3, here's 1, here's 1, so 1 minus 1 is 0, so then you go back to 0 at here. So the resulted graph of this one is just a box, okay, just a box. For some cases, then I might have a, let's say, e to the power of let's say negative 2, okay, t minus 1, okay, and multiplied by t, okay, minus 2 minus u t minus 3. Okay, well, when you multiply this one here, okay, then the first step is you draw the graph of this exponential function. Okay, exponential function. Then this exponential function is an exponentially decay function. Okay, will look like this. When t is 0, apparently this number here is e to the power of 2. Okay. Now if I multiply this function with the box over here, so these two, the product, okay, then what would I see it here? Right? What would I see? Then basically it's like a cookie cutter. Basically the multiplication here, you see, then you would think, okay, at the t equal to anywhere, you know, at maybe t equal to 1, okay, there's a value here, but there's nothing here, right? There's nothing here. So non-zero multiplied by 0 give you 0. This is why we are looking for the so-called overlap region. Then the overlap region means the region that both curves or both graphs are non-zero. Okay. Then the product will give you a non-zero part, right? Apparently this portion is non-zero and this portion is non-zero. Okay, then the product out of the two graphs, okay, will give you between 2 and 3, okay, and 2 and 3, and the portion, okay, of this exponential up to here. Okay, which is basically this guy here. Okay. Then you probably want to ask, okay, so then what is the value between when t is greater than 2 and less than 3. And what is the value of this graph? So the value of this graph is simply of this. Right? When the t value is within this range, then you don't have to write this unit step function anymore. You can only just write this exponential function at here. Right? Just write this exponential function, and you can get rid of that. And this is actually why in some of the exercises of the convolution, you can get rid of this scary unit step functions. Okay, for example, in one of the assignments, in the latest assignments that you have here, and we are talking about a convolution. Okay, so for example, you're talking about a convolution of let's see, you're talking about the convolution of this graph. Okay, I don't quite remember. Let's just talk about this function here. Maybe just this one here. Okay, so I'm gonna change this one to tau. Okay, t to tau. Okay, let's say I call it x of tau here, and I want to convolute. Okay, and a convolute of another function, which is, let's see, another exponential function. Okay, another exponential function here. Okay, so this is e to the power of negative t. Okay, u of t. Let's see. Okay, yep, so this is t here. Okay, and let's say this is also t. Okay, this is t. Let's put t, and then we'll change that to tau. Okay, so I want to convolute these two guys here. Okay, then what do I do here is, okay, then I'll keep this ones not changed. Okay, I'll keep these ones, but I just change this one to tau, right? So this portion here, okay, this is like u t minus 2 and minus u t minus 3, right? So that's this guy here. Just I change this one to tau. Okay, so overall it's this. Okay, and of course this side you do the reflecting, right? You do the reflecting, which becomes h over tau, and you do the shifting, okay, and shift by amount of t, right? So what do we do next is, okay, another compare edges. For this guy here, I have two edge. Okay. So there's a tau equals to 2 is one edge, and tau equal to 3 is one edge. And here there's edge at the tau equal to t. Okay, so then apparently they will have overlap. Okay, when t is greater than when t is greater than 2. Okay, when t is greater than 2, so overlap occurs. Okay, then the relative location is, let's say if this is tau equal to 2 and this is tau equal to 3, and when the edge of tau equals to t is within the two edges, and that means t is greater than 2 and less than 3. So that's one case, right? That's one case. Okay, so in this case here, you will have your graph look like, and you will have your graph look like this. Okay, that's one graph, and the other graph will be like the here. It's t, 2, 3, right? So now you know that with this amount of shift in t, you can place this edge between tau equal to 2 edge between tau equal to 2 and tau equal to 3, and the regional overlap is the next one you're going to find, right? How do they overlap? And because that's basically the product of the two graphs. Okay, so apparently the overlap happens between here because this two portion, right, is the portion that give you the graphs. Both graphs are non-zero. Okay, then for the tau value, and that's between 2 and t. Okay, so then the convolution will simply become 2 to t Okay, the product of the two graphs. So bear in mind, what are the product of the two graphs? Okay, now this one here is given at top, but now since your tau is within 2 and t, okay, but since your tau is between 2 and t, then you don't really have to worry about this anymore, right? Because between tau equal to 2 and t, this whole portion equals to 1. Okay, so then for the product of these two graphs, essentially just that portion, which is e to the power of negative tau 2 tau minus 1. And how about this guy here? So this is just simply this. Okay, how about this portion here? Right, this portion, and this portion is your ht minus tau, okay, which is e to the power of negative, okay, t minus tau. Okay, as you can see at the beginning, because the original function is e to the power negative t. Okay, and you don't have to have this u of t anymore. Why? Because over here the unit step function is 1. Okay, is 1. So multiply with this d tau, and then you can do the rest of the integral for this case, right? Now, of course, you keep shifting, then you will have another region of overlap. Essentially, the other region of overlap is going to be, if this is tau equal to 2, and if this tau equal to 3, then the other edge is over here, tau equal to t here. Okay, so that means when t is greater than 3, okay, then you can try out the other edge here. Okay, then for this case, you will see that when the tau is greater than 2 and less than 3, okay, that's your region of overlap, or the range overlap, which is basically the integral for the convolution. Okay, the integrand won't change. It's still this. Okay, and nothing changes. You can do the integral here. Okay. I think I still want to point out one last thing is, bear in mind e to the power of x plus y equal to e to the power of x multiplied by e to the power of y. And if you have e to the power of xy, and that's simply just like this, okay, or like this. Okay, so make use the right formula to do the simplification. Okay, don't make any apparent mistakes here. Okay, thank you. Bye.